Okay, class. I've been asked to do the simulation number 2, the Coulomb's law triangle problem. And here it is over here. We have an example. I'll go ahead and draw it out right here and see what we got going on. So we have this here, and we have a little X mark here, and we'll call this here, this is, we'll call this Q1 right here, and it is positive 5.9 microcoulombs. And over here, we'll call this Q number 2, or charge number 2, and it is a plus 30.7 microcoulombs, like so. And then we have this right here, and we have a we'll call this charge number 3. We'll call it Q3, and it has a value of 17.5 microcoulombs. All right, and the question is calculate the net force and direction, magnitude and direction on charge 3. So how are these two? How is charge 1 and charge 2 affecting charge 3? That is our goal. Well, anyways, since this is positive, 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 they're going to feel repulsive forces. In other words, Q3 is going to experience a force by Q1 in this direction, and Q3 will also feel a force, Coulomb electrostatic repulsive force, Q2, going in this direction here. So in a way, we probably draw this to kind of get us initial feeling. Force is acting in that direction, and force is also acting in that direction there. Okay, and maybe we call this here maybe theta 1 for right now, and we'll call this over here theta 2. Okay, now we have some more information. This is going to be 0.30 meters here. This is going to be 0.116 meters here, from here to here, and 0.3 meters from here to here, and this here is going to be, let's say, 0.327 meters, like so. All right, so a couple of preliminary information before we do anything here is, first of all, let's calculate what this distance is. We'll call this D1, and we'll call this over here D2. So let's do this first. Okay, so D1 is going to be the square root of, so we're going to do the Pythagorean theorem here, do 0.116 squared plus 0.327 squared, like so. And let's go ahead and see what D1 is. I get my calculator here, second function square root, so I'll do 0.116 squared plus 0.327 squared. And we'll go ahead and close it and see what we get. All right, so we have the distance is going to be 0.34, we'll say 7 meters. So we have what this distance here is, because we'll need that for Coulomb's law here a little bit later. So let's go ahead and do D2 here. So D2 is going to be, using the Pythagorean theorem, we're going to do 0.3 squared plus 0.327 squared. And let's see what that is. Second function, 0.3 squared plus 0.327 squared. And let's see what we have here. This ends up being 0.444 meters right here. All right, so looks like we're good here. We have this distance here, we have that distance there. And okay, so at this point, what I like to do is, once I have the distances down, is let's reformat or recenter the problem. So in other words, what that means is that, well, we can, before we do that, let's maybe go ahead and take a look and see what theta 1, well, let's go ahead and center it. So here is the origin. This is now going to be Q3 right here. And let's go ahead and draw like an XY axis like that. And we'll go ahead and draw this like that. So we have an XY axis. And so what happens is that since this is a vector force, we're going to put it here. And I'm going to go ahead and whatever this angle is here, we're going to go ahead and kind of draw this out right here. So this is going to be force, we'll call it force 1 on 3. And here's the angle theta 1 here. And this force here is a vector we can go ahead and put it here. So we're going to go ahead and maybe kind of draw this like that. And we're going to go ahead and call this force 2 acting on 3, like that. So these are vectors here. And now what we want is we need this angle here. So I'm recording. I need this angle right here, which we will call theta 2. Okay. All right. So because everything is always from the positive x-axis. All right. So some preliminary information here. So what we'll do is going back up here. Here's theta 1 here. Probably should have done that first. So we'll go ahead and do theta 1 is equal to the inverse tangent, and here we have so the tangent will be 0.327 divided by 0.116, and let's see what theta 1 equals, and make sure that we're in degrees. So let me do mode, and I'm in degrees. We'll hit clear. So I'm going to go second function inverse tangent, 0.327 divided by 0.116, and I get about 70.5 degrees. So that's this angle right here. Okay, so that means that that's so if we extend it out like this here, it'll be this angle right here. So we see that theta 1 is 70.5 degrees right here. So now let's take a look and see what theta 2 is here. So theta 2 is going to equal okay, tangent minus 1 of 0.3. Honey, I'm recording. 0.327 divided by 0.3 right here equals second function. Okay, let's hit clear. Second function inverse tangent 0.327 divided by 0.3, and it's going to give us 47.4 degrees. But we've got to be careful. Okay, so that means that this angle here, so this is really, we'll call this theta 2 prime. This is really theta 2 right here, which is 47.4 degrees, but we actually need this angle here. So theta 2 prime will be 180 minus, we're going to say 47.4, and that equals 132.6 degrees. So that's going to be theta 2 here. Okay. All right. So now I got my angles. Now all we need to do now is calculate the forces. So I'm going to go ahead and use an online calculator because I don't want to do too much work here. So let me go ahead and open up. Let me go to up here, and I'm going to type in Coulomb calculator. So C-O-U-L-O-M-B calculator. Okay, and so Coulomb comes in, and I've used several of them that you can use. Go ahead and pick one right here. All right, so we'll go ahead and see like here. Let me we'll go right. We're still recording, and okay. So charge 1. Let's go ahead and low here. So we're going to be in just regular coulombs. Okay, actually it's a micro coulomb. So make sure we're micro coulombs, and we're micro coulombs. All right, so charge. So let's take a look at this force right here. Force 2-3. Okay, so that's going to be right here. Force Q2 on Q3. So we're going to use charge right here, which is 30.7. 30.7. Okay, and charge this charge over here is 17.5. So 17.5. Okay, and the distance is in meters. Let me go ahead and get meters here. And the distance here, D2, is 0.444. So 0.444, and that gives me, we want this in newtons. And so, force 2-3, right? So this force Q2 on Q3 is actually right here, and we have here that this force is actually 24.49 newtons. Okay, and let's go ahead and do this force here. And this will be this force, which is Q1 on Q3. So Q1 is 5.9, so we'll 5.9. Okay? And this charge here is 17.5, is still the same. But D1 is 0.34. This is 0.347. Okay, and that gives me 7.71 newtons. All right, so I have force 1 on 3, I have force 2 on 3 here, and I also have the corresponding angles here. Okay, so double check here. Let's see, what was it? Yeah, so yeah, Q, yeah. So this one here, this is theta 1. So force theta 1 we had was, I think we said it was 70.5. Okay, so double check here. So this force here was 70.5 degrees, and this force here, force 2, 3 had theta 2 prime of 132.6 degrees. So I have magnitude, direction, magnitude, and direction. So I'm going to go ahead and pick my favorite online calculator. And let's go here. So go ahead and vector calculator. Vector calculator. Let's see what I got here. Vector calculator math. I don't know if it's fun or not. Here we go. Okay, so I'm going to put in magnitude. So the first magnitude we're going to put here is 24.9, 24.49, and the angle is 132.6, 132.6 here, 132.6, and this force here is 7.71, and the angle here is 70.5. 70 point, and we'll go ahead and do that. So what happens then is that the resultant force based on the online calculator is going to be 28.9 newtons, and theta is going to be 118.96 degrees. And if we look closely here, here 90, then 132, so 118 seems reasonable. All right, so there it is, and well, hopefully this will help you out.